Hello grade 7s. Today we are going to go over 7.3 adding mixed numbers. So just to review, a mixed number is a whole number and a fraction. And it usually looks something like this, where you've got a whole number and then a fraction. Graphically speaking, for this case the whole number is 2, so we've got two whole rectangles that are filled in. And then we've got a partial rectangle which shows the fraction 1/3. So one section is shaded out of 3. So that is 2 1/3 there. So our task is to add mixed numbers and then write the answer in lowest terms. And in this case we have the question 1 5/6 plus 1 5/6. So method 1 is to use pattern blocks. And we'll just keep this on the screen so that you can see the question that we're working with. Here we've got one whole unit, and then we've got 1, 2, 3, 4, 5, 6 pieces here. So that's part of another whole unit. This is 1/6. Two of them makes it 1/3, because you can have a third of it here. And then 3 pieces together creates half of the shape. So that's what this is. This here demonstrates our equation. One whole and then 5 of the 6 are in place, plus, so just like the question up here, another whole one and then 5 out of the 6. So because we're using the pattern blocks, it's very easy to combine the two whole ones together first. So that's 2. And then you can add the triangles. So we've got 5 here and 5 here. If we take 1 from here and put it into this slot here, that creates another whole unit. So that's, numerically speaking, we've got the two holes that we already put together, and then we're adding the 5, 6 and the 5, 6 together. So we've moved one triangle from this piece here over to fill in the gap that's missing there to create this third whole one, and then it leaves 4 left here. So once you've done that moving, you can regroup everything, and you'll see you've got a whole one, another whole one that's made up of the partials, and then we've got 4 out of 6 shading here. So we've got 1, 2, 3 and 4 6, which is what we can see here. We've got 3 4/6. The two holes, we've created 6 out of 6, or 1, by moving this one piece over, and then we've got the 4 6 left over from this one once we pull the extra triangle out. So it's 3 4/6. So that is our answer of adding 1 5/6 plus 1 5/6. However, that's not lowest terms. When the numerator equals the denominator, the fraction is equal to 1. Yeah, that's just a reminder here that 6 over 6, which is what we did here, we have 6 out of 6 shaded, that converts to a 1. To write the answer in lowest terms with tiles is not the easiest thing necessarily to visualize. The 3 holes will always be 3 holes. When you're reducing to lowest terms, the whole number never ever changes. It's only the fraction part that changes. So we're changing the 4/6, and in this case it's going to convert down to 2/3. But you might be able to see, because we've got 4 out of 6 shaded here, oh wait, this piece here looks a little bit like this piece here, which is a third. So there's 1/3 missing from this shape. And if you can see that, then you must realize that if 1/3 is missing, then 2/3 is what we have left. And then you can actually change those triangles out for these other shapes to have 2 of them, and it's the same amount that's covered in this hexagon. So you can see that 3 4/6 is the same as 3 2/3. So here's a little tip. It says look for the largest pattern blocks that can make up the same shape. A rhombus, which is what this shape is the same as 2 triangles. So yeah, we've got 4 triangles here. We can go back and say, okay, well we've got 4, so we can't use the whole 6. So that one we're not going to look at. The next biggest is 3. Well, we could do that, but we want them to be all the same size. And if we take out 3, then we're going to still have a 4th one left over, so that doesn't really work either. But we've got 4, and this one only takes 2 of them, so we can use 2 of these to create that space, like we've done here. So each pair of triangles can convert to a rhombus, and so that's the other way to look at that. So method 2 is using improper fractions. And an improper fraction is a fraction with a numerator that's greater than the denominator. So the top number is the numerator, and the bottom number is the denominator. So an improper fraction, the top number is bigger than the bottom number. So here's our original question, 1 and 5/6 plus 1 and 5/6. We can separate the wholes and then separate the fraction parts so that we can add the wholes together. 1 plus 1 is just 2. And then if we're adding the fractions, well, we need to have a common denominator, and in this case we do. We've got 6's in the bottom, so our answer is going to have a 6 in the bottom, and then we just add the tops. So 5 plus 5 is 10. So we have 2 plus 10 over 6. 10 over 6 is 6 out of 6 plus 4 out of 6. Because this number is bigger, we can take 6 out of this, which is what we've done here, and then the remaining 4 is another fraction here. So we've got 2 plus 6 over 6, which really is just 1, plus this 4 over 6. So now we've got another addition here of whole numbers. We've got 2 plus 1, because we've pulled the 6 out of this 10 and created a 6 over 6, which is just 1, plus we've got the 4/6 here. So yeah, as an improper fraction, you can think of it. 10/6 is the same as, well, it goes once, so there's going to be 6 over 6 with 4 remainder out of 6. So once again, add your whole numbers. You've got 3, 2 plus 1 is 3, and we've got the 4/6 left over. Now, we know to put this into lowest terms, we can divide by 2 because 4 and 6 are both even numbers. So divide the top by 2, 4 divided by 2 gives you 2. Divide the bottom by 2, 6 divided by 2 is 3. Again, when you're putting in lowest terms, the whole number never ever changes. It's just the fraction part that changes. So it becomes 3 and 2/3. So again, 1 and 5/6 plus 1 and 5/6 is 3 and 2/3. Both methods come up with the same answer. Whichever one works best for you, you're welcome to use. So, now there's an opportunity for you to do a show you know. Please go ahead and do that.